This week we're talking about Punnett squares. A Punnett square is just a box. It has 4 boxes representing the possibility or probability and outcomes of what could happen. Specifically, what will happen when a male and a female join their gametes at one specific allele. An allele is just a gene, and it's usually represented by a letter. For example, the letter T. So we're going to talk about the letter T today, and we're going to say that T is the tall gene. So let's say in this example that both mom and dad are tall, but they're both heterozygous. So they both are tall, but they carry the not tall or small gene. So we're going to put mom's genotype on the left and dad's genotype towards the top and see what happens, or what's the possibility and what will their children look like. So we've just finished putting in mom and dad's genotypes. So now using this monohybrid Punnett square, we can actually figure out if the children, what is the probability that the children that they produce will be tall. In the first box, it's going to be big T, because you're combining the row with the column letter. And then you just complete the rest. Remember that what's inside the monohybrid Punnett square is a possibility. It has not happened yet. Since this is a possibility or a percentage, it's kind of like rolling the dice. You're trying to figure out if it's head or tail, or if the child is going to be tall or not tall. The genotype ratio is a ratio or a fraction, and it's out of 4. So 1/4 of the children might be big T. You could also say that 25% of the children will be big T. And then 2 out of 4 will be big T, little t, heterozygous. Or you could also say 50% of the kids, there's a 50% probability that the kids will be heterozygous. And then lastly, 1 out of 4 might be little t, or 25, there's a 25% probability that the kids will be little t. Next, in the phenotype ratio, we're not going to be looking at the genes or the genotype. We're going to be looking at what the child looks like. So if you look at a phenotype ratio, it's just, is this child tall? Or is this child not tall? And if we do some counting, we can just figure out that there's a 3/4 chance that the child will be tall, and there is a 1/4 chance that the child will not be tall. And that's shown in the last box.